Yeah, you're good.
Oh my gosh, that just startled me. It told me very loudly that
Mm.
this meeting was being recorded. All right, everyone. Good morning. Thanks for joining, or for you guys, I guess, happy lunchtime. So my name is Mikhayla Gander. I'm an application engineer with Greenheck in our applied products group. So today we're going to talk a little bit about the different options and solutions that we have for high performance outdoor air equipment. Just a little bit real quick on why outside air, why do we need it? I know it's something you are all well and familiar with, but we'll still cover that real quick. And then we'll really dive into some new products. That's where stuff gets fun. So I figured we'd do something a little different than the normal and talk about that today. So, why outside air? As you've all lived through it, you've been aware, right? The industry is really facing two different opposing kind of crises. One of them, after COVID-19, everyone realizes that we need a lot of outside air in order to increase safety from any airborne pathogens in spaces. So, a really easy way to mitigate that risk is to bring in more outside air and ventilate more. Well, that is something that we know how to do. It is very costly and and consumes a lot of energy. So, that kind of ties hand in hand with the other thing the industry is looking pretty largely at right now, which is growing concern over impact of energy consumption. So, despite how any of us might personally feel on this one, the reality is that state and national codes are regulating building design, and that's making it pretty challenging for meeting different efficiencies, things like that, in order to reduce carbon emissions. So, the end goal is, you could say, a good one, but how we get there has been a challenge in the industry. So, we do have a big push for both of those things, bringing in more ventilation, specifically fresh outside air, but also reducing energy consumption as well. So I'll just kind of go through this really quickly, right? Building designs are getting much better, which is reducing our overall sensible loads in new buildings. This isn't going to be the case necessarily for retrofits, but this is what we know about new buildings. So sensible loads are going down, but latent loads are staying the same, right? The people in the space, the occupancy, that you could maybe even say they might go up a little bit as we've seen ventilation requirements increase. But ultimately, it's a decrease in your total load, yes, but it is an increase in that percentage of your latent total load. So now that it's a lower overall, that latent plays a bigger impact, is really what I'm saying here. So we have to talk about outdoor air and how we can manage that effectively. Just kind of highlighting real quick what we said before, right? We know we have to bring in more outside air, but what is the challenge surrounding that from an efficiency? Can I just bring it in and call it good? Maybe in some climates that is absolutely an option. You guys are a perfect example of a climate where that would not be a good option, right? It gets really hot, really humid. And there is this study, lots of studies out there that kind of show where different allergenic or pathogenic organisms thrive and where they grow and spread fastest. And that tends to be in really high humidities or even sometimes in lower humidities, depending on the type of organism. So what they've identified is this optimal relative humidity zone, and that's going to be that like 30 to 60% range. So this is why when we talk about ventilating further, it's not just as simple as bringing in more outside air. It's also dehumidifying that outside air and making sure that we're managing that optimal RH zone for buildings and spaces so that we also satisfy the desire for people to stay healthy. So, that being said, that's why we're talking about outdoor air equipment today, specifically in the different solutions that exist. But before I dive into that, I'd be remiss if I didn't show you. When I say Greenheck, most of you probably think of everything on this slide except maybe our outdoor air solutions. So most people, when they think of Greenheck, right, they think fans. They think all the stuff kind of surrounding the outside edges of this slide. So what we're really talking about today is going to be these center items here. So with that, we're going to start by talking about energy recovery specifically. Big thing for you guys down in Georgia. It can help quite a bit. Why do people talk about energy recovery? Big part of the benefits is that it's going to reduce heating and cooling capacity and improve your energy consumption, right? So giving us a way to bring in that outside air while reducing overall energy usage. So important to know, or fun trivia. I don't know, maybe Holden will use it in a future trivia opportunity for you, but every 1,000 CFM you put through an energy wheel and I'm talking a total enthalpy wheel, that's about a 3 to 4 ton mechanical cooling reduction. So that can play a big impact on overall energy consumption. And then cores are out there too, but they're about 2 to 3 ton for every 1,000 CFM. Another benefit to using energy recovery is going to be that it reduces the variability of your entering conditions. So really that's going to lead to is more stable operating ranges and less cycling of your furnaces and your refrigeration equipment. The less we cycle, the better for our energy consumption as well. And then I have to say it, but it also just conforms to different federal and local codes depending on what you've got in your area. So that is another reason that we talk about energy recovery. So we've done energy recovery for a long time. You've probably seen standalone ERVs from us. We started those about 30 years ago. So that's going to be your ERV, ERVE, and your mini vent units. So you might see those out there. And you might have also seen energy cores out there. ECVs and mini cores would be our model names for those. So those have been out. Those are kind of our bread and butter when we first started with outdoor air equipment. But that's not actually what I really, really want to talk to you guys about. What I want to show you more than that is actually going to be indoor ventilators. So this is something that's been a big push for a long time. Our reps have been begging us to have an indoor option that can make sure that, eventually we'll be able to do a full indoor DOAS offering with a low profile unit, modular construction. Those things were really emphasized to us because of the fact that a lot of jobs out there are tight on space, right? Space is a valuable resource. So that being said, we did launch a new product line earlier this year, maybe even late last year, and that's going to be the ERVI. So it stands for Energy Recovery Ventilator Indoor. So we got real creative there, but what this is it is a modular unit. So you could have it like what you see here, but let's say that, you're in an area where you have to worry about frost control and you want to preheat. Well, we have options to add different modulating or different modules with heaters in there or whatever you need based on your situation. You will see slightly different model names out there. You might see the ERVI, that would be a standalone energy recovery ventilator. We had to get fancy with it and change the model name when adding a tempering device in there. So the IVE is really the same thing with that extra module built in, and that's going to be actually post-heat in this example. Now, that being said, there are two different housing sizes. It's either going to be an 18-inch height or a 23-inch height, and then the length is going to vary based on how you select it, whether you have that preheat, post-heat, or hopefully different things coming down the road. The long-term goal, like I said, was going to be to target a full indoor DOAS offering here. So we are going to try for an IV. So maybe this one doesn't have energy recovery, but it has different cooling and heating options than what we have right now. So as it stands right now, it's going to be the wheel with electric heat available. Hopefully we can get some water connections in there as we keep moving. And then also just a standalone heating and cooling modular unit for tight indoor spaces. So some things we've done for this are kind of taken into account from the engineering perspective on this one that we hadn't done before was figuring out how do we make sure that this has a low profile design. Biggest thing we heard from our reps is it has to be able to fit into those tight spaces. So this was actually designed to fit through 30-inch doorways, with the overall unit height being that 18 to 23 inches. So it does get quite a bit long, but it is able to be broken down to fit in those tight spaces. We were also informed that people really wanted to make sure they had tempered and non-tempered options. And this really comes down to the fact of it's not just one climate zone in the US, right? So we have to make sure that people have what they need no matter where they are and what climate they might be designing around and in. So right now it's got that electric post heat, and then hopefully those additional options will come soon. Those are in the works right now with that chilled water, hot water, and hopefully split design in the future. And then biggest time you're going to see a good use for this is going to be space constrained applications. So it has the ability to be ceiling hung, fit in small mechanical rooms, basements, crawl spaces, you name it. So that is a big benefit. And then this one's actually going to go up to 2,500 CFM. So quite a bit for how small the unit itself is. Key applications for this one, we're really seeing a good fit for this in retrofit or modular units. Again, that retrofit being the biggest driver for this. There's a lot of that market, I feel like, especially in bigger cities. So schools, nursing homes, or buildings that have pitched roofs, this is also, what do they have in common? Limited mechanical space, needing that low profile. So that kind of tracks for that. High-rise buildings. So I've had a couple engineers and people talk to me about using this in multi-level projects where they just can't have a DOAS unit on the roof, or it's really difficult and pretty costly to do so. So I've heard for that as well. This has been pretty helpful so far. And then just decarbonization projects. So energy recovery can be a big help with air source heat pumps, things like that. So we're seeing them kind of paired in that realm at this point too. So I don't have a ton on that one. I really want to drive towards the next two, but just so you know, that is out there, that is available. Now, rooftop equipment is another new product that we've launched. So quick overview, I won't kind of dive in too deep, but there's a scale out there for rooftop product on how much outside air they're bringing in, that kind of 0 to 100%. On the 0 to like 30-ish% is typically, maybe even 20% is where you might have seen traditional rooftops. Normally, these are going to be limited configurations, lower overall airflows, and then they don't typically dehumidify very well. They were more originally designed for kind of that comfort cooling, not that dehumidification aspect. So then you get up into those higher percentages of outdoor air and you start seeing that high efficiency RTU. You start seeing high capacity RTUs and then true DOAS units. So when that hits, varies depending on climate from outside air percentage, but usually you could see it anywhere from 20% on the low side up to 100% on the high side, really needing those more efficient, higher capacity product. So that's where in our prior state, we had the RV product line and people were using it kind of that 20 to 100%, but at that 20%, that kind of lower zone, it wasn't necessarily the most cost-effective option, but they needed it to get the good dehumidification and space comfort. So Greenheck has recently launched a rooftop product. I think it was late last year, last August is when we first started seeing some get ordered. So this is really intended to be optimized for today's building, so still able to handle that latent load that we talked about. Have an expanded performance range comparatively to your traditional rooftops. It's still intended to be able to dehumidify, so it will temper how you need it to, but that's the biggest differentiator, I'd say, between a traditional rooftop and the rooftops that we're launching is they are still intended for dehumidification as that primary purpose. And then enhanced features that we were using in the RV product, but since it's in a true rooftop package, you are going to get that lower cost ability to fine tune your airflow, your temperature, and humidity. So what does it look like? That's what you really want to know, I'm sure. So this is what it's going to look like. This is the RT up on the upper right corner. So again, standardized on modulating components to get us that ability to dehumidify and provide tight temperature control. We're going to offer this one with package DX and air source heat pumps. From a heating standpoint, indirect gas, electric heat, or air source heat pumps. So on this one, control sequences are going to operate very similar to the RV that we had launched. You'll see 4 different cabinet sizes out there. On the package DX side, most of them are already available. Air source heat pump, we're about halfway to where we want to be. And then early 2026, we'll see everything else fully open up and be orderable. So that's where we're sitting with that. But I do want to highlight, right, this is a new product. So with new products, we dive into some different design challenges and opportunities. So I'm not going to go too in the weeds on the RT, but just some key things that they were thinking about as they put this unit in design. Really making sure that from a square footage, just pure footprint standpoint, they were matching competitive deck dimensions that are out there today. One thing they did to help mitigate that footprint was do a U-shaped condensing coil. So that's something that we hadn't done before. So you'll see that U-shaped condensing coil on there that optimizes performance while minimizing footprint. So that was really helpful. And then also when launching this kind of product, I have a couple photos and a very short video later, but the facility being built for this is actually where we are introducing the most automation that we've ever used in one facility. And so one thing they did to really help with the whole process as it goes through the shop floor is try to design more drop-in sub-assemblies. So that's the picture you're seeing on the bottom right side right now. So this makes it easier for manufacturing. It also makes it easier for serviceability in the field over the lifetime of the unit. So all of those things were being thought of from a square footage standpoint. How do we maximize performance and footprint? And then also just how do we make this easier for both the shop and the field in the future? But I think something we often miss and don't talk about, and this is kind of an example of something you wouldn't think takes so much thought. But even when it comes down to insulation, like thoughts that they're thinking is, let's compare different options, right? And they will really go through and they will make a pros cons list essentially for everything. So this cabinet, as an example, we did go the injected foam cabinet construction for all the reasons listed there. But the reason I really want to show like this list is less about that the route we chose to go, but more about the amount of thought that goes into a design like this and how much they really are looking at, how many different options they're comparing, especially compared to industry standards. So just a little behind the scenes view of what a lot of people don't see in the project design phase. All right. So this video on the bottom is playing. I didn't hit play, it just decided to go, so we'll go with it. So all of these different machines are items that we put in the RTU facility. That's going to be down in Tulsa, Oklahoma. So the night train that it was just showing actually pairs with what's called a Prima system. And the Prima has a panel bender in it, along with some other items as well. And as you can see, you can expand on the panel bender and have it help with unloading. You can have this machine help with your sheet stock storage, your punch, your shear. It's really more than we've done in a facility. We've used bits and pieces of them, but not all of them together all at once, which is really cool to see. The other thing, I'll see if I can hit play on that. That above that, this picture here, that is actually, it's essentially a little moving robot that is going to help pull parts from one area of the facility to the next. So I haven't actually got to see this guy in action yet, but I'm really excited to go see how that's going to help us and really help move things along in the facility. And then this one over on the right, most people probably aren't going to know what this one is. So something we do, right, we talked about insulation very briefly, but we utilize injected foam insulation on the rooftop product and the DOAS product. And that is one of the most challenging parts of the manufacturing process. It's really messy to use an injected foam, right? Because you have to squeeze this liquid foam into pre-built panels. And normally you're going to have a lot that as it hardens and expands, you just kind of have to shave off, things like that. It gets really messy. So one thing they worked really hard to find was a way to make this less of a manual process and more of an automated process, kind of taking it from more of an art to more of a science. And so that is actually what that machine is up on that upper right. So that's going to be a really big benefit for the rooftop facility. Aside from that, it gives some other benefits too. It's cool. It'll be fun to see. We're excited to have people down in Tulsa someday to show off the factory and make sure everyone gets to kind of nerd out, right? We're all engineers here. So that will be an exciting time, but end result for this, we are going to also be able to increase our throughput as a result, have higher consistency of the product that leaves the shop, and overall better quality. So there's a lot of other reasons to automate outside of just it's really cool, but it is really cool and really fun to do as well. All right. And last but not least, kind of diving into some enhancements on the roof or the RV product line. So if you've seen our DOAS equipment or RV models before, you might have seen there's 3 different model names. So RV, RVE, or RVC. So you could have had energy recovery really is what that is. So an RV would be no energy recovery. RVE would be like what you see on the screen with a wheel inside of it. And then an RVC would be with core instead of a wheel. So a little bit more expansive on the cooling options on the rooftop. So this has Package DX air source heat pump, but it also has chilled water available. And then similarly on the heating side, you've also got that hot water connection in addition to the other things that we talked about for the rooftop. So the indirect gas, the electric heat, and the air source heat pump. So in these cabinets, we are 3 ton on the small side up to 100 ton on the large side. Now that is new. So we just launched this new cabinet. I joke and call it our extra large cabinet, or it's the RV220. It's going to be 50 to 100 ton package DX cooling. It really allowed us to expand our overall airflow range. So we went from 18,000 on the high side is what we could do before, and now we can go up to 29,200 CFM. So quite an expansion on that perspective. And since we're moving more air, we needed bigger heat options. So you'll see that as well. There are some caveats to this. I will say you'll see that it says Energy Wheel coming in April of 26. So we did I'd call it a soft launch almost right now. What you can get with this one is going to be supply and then package DX. And that's really the limitation right now. Package DX, you've got your electric heat and gas heat available, and then supply only. So in April is when we're expecting to be able to roll out some more features with having that exhaust fan and energy recovery tied in as well. I believe in December too, we're adding water connections available in that one too. So quite a bit coming. If you're curious what it looks like, it is not the unit up on the screen right now. So we'll take a look at the different housings we had. We had that 3 to 7 ton in the upper left right now, all the way to what was our 30 to 70 ton on the bottom left. And that, as I call it, the extra larger, that 220 is actually going to look like this. So if we really study these, I know I didn't give you this exact same look on all of them, but there's a couple things I want to point out right off the bat before we move on. And that's going to be, you can see that the 3 to 7 ton I talked about had top condensing, as did the 30 to 70 ton below it, also a top condensing. The other two options that we had were both side condensing. So when we looked at this new product, as you can see, we chose to not go with either of those options. We actually did end condensing. We'll dive into a little bit on the whys later. You can also see that my compressors are mounted externally versus on the other images, we don't see any compressors. So those are all mounted internally. So that was a bit different as well. And there's a handful of other differences, and I'll kind of pinpoint some of those for you. But that is what it will look like up close and personal. This is what you'll see for drawings. You'll see, right, that same stuff we kind of talked about, that end condensing, honing in even more on the condenser section. So what you'll see there is 6 condenser fans, which does not sound like a ton of fans for up to 100 ton. That was the first thing that I told our engineering team is, how are we doing that? So 6 condenser fans, and then again, that end mounting. So prior units, that has looked a lot different. That being said, we kind of started touching on considerations and what goes into engineering from a design standpoint with a rooftop. You can imagine there were equally as many questions that we had to think about and just make decisions on when it came to the RV220. So I did actually get some feedback from our engineering team that I'm able to share with you guys on some of the biggest things that they had to think about and biggest questions that even our reps asked us about. And one of those being that first one up there, right? We had done top and we had done side condensing before. So why end condensing on this unit? And the answer personally surprised me, but it really came down to how can we transport this type of product as effectively as possible? And the feedback we had gotten from kind of industry, from talking with key reps that helped in the design process, things like that, was that it was important to maintain a footprint that would still allow for standard shipping dimensions. So that meant that they needed the product to be less than 102 inches long. So if we had done side or top condensing, then what we would have seen happen is we would have had to reduce our evaporator coil size, which wouldn't have gotten us up to that 100-ton capacity. So it really plays into, okay, what tonnage do we want to achieve? What's reasonable, what's not, and how do we also still adhere to maintaining simple transportation for this type of product? Which is not what I thought they were going to tell me, but that ended up being what was the driving factor there. So then I had asked them, okay, well, if we were set on this number of 100 tons, why did we decide to go to 100 ton or not do a little bit less or a little bit more? Because maybe we could have done, 80 tons and still fit on the flatbed. Why not go that route? And so essentially for this one, engineering came back and said that the goal was to maximize capacity within the cabinet size that we were constructing. So before we offered up to 70 tons, so making a whole new cabinet to just go to 80 ton wasn't necessarily something that people felt a need to do from an industry standpoint. So going up to 100 ton was kind of the area where it gave people a lot of flexibility, gave them more options that they would be able to use in the field pretty quickly. Going above 100 tons, why we didn't go that route, because originally we had kind of debated, do we do 100 up to 120? Where is that cut off? And again, surprisingly enough, that comes down to how do we help people transport these things and meet the majority of schedules and market demand that people need. And going above 100 ton would have meant going up to that oversized shipping, making overall costs much higher, complexity of even just transporting product much more challenging, things like that. So again, really comes down to balancing capacity and transportability of the product. Another really big question that we've gotten asked is, why did we mount compressors externally instead of internally like we did on all of the other product that we've launched so far? What was the driving factor there? So engineering's thoughts on this one actually came down to that big shock. If you mount the compressors inside the unit, it would have increased our overall length of our unit, which would have increased our weight, which would have made shipping harder. So transportability again. And then the design that they ended up going with actually had other benefits in terms of load distribution for your refrigeration circuit, and then shorter piping runs as well. So shorter piping runs also lead to better serviceability in the future, not as many opportunities for leaks, things of that nature too. So kind of falls into that side. And then kind of talking about that serviceability and even manufacturability, those were also big deciding factors in the overall layout. So that is kind of where that fell. Next question that they were able to get us some feedback on was, how many condenser fans did they go with for the 100 ton and what size? So they didn't give me a direct size, but they did use 6 condenser fans, which if you'd had any or seen any of our older products in the field, some of our 70 ton units had up to 8 condenser fans. So the question I had for them was, how did we get down to 6? And that really came down to increasing the diameter of the fans we were using. So they were able to do that here as well. And again, that just kind of helped with overall design, keeping costs lower, weight lower, things like that. So those were all big factors. And then the question I was most interested in, that they probably could have wrote me a novel, if I'm being honest, was, were there any challenges in manufacturing process that we hadn't experienced before? How was manufacturing impacted? How did we overcome any challenges that may have come our way? So I kind of lumped all those questions together when I asked them. And essentially some things that they had informed me, this design is officially the product with the highest percentage of components that are using a Prima automation system. So we looked at that video that on the rooftop product, that was a Prima automation system. We have that in DOAS, but we don't have it to the same capacity that the rooftop business unit is getting it. So they've got a couple extra tools and machines and things that we don't have on the DOAS side. So to increase the percentage of components actually utilizing that system took a lot of effort and behind the scenes redesign of components we'd used in the past, even to make sure that that could smoothly flow through the shop and also allow us the ability to keep lead times low. Because offering a product like this is really cool, but if lead times just go out into the 20 plus weeks, then it's not really feasible. So that was something that was a bit of a challenge for them. That being said, the sheer size of the equipment was also a challenge that we hadn't had to overcome yet in the facilities based on what we've been building. So they did have to make adjustments to tooling and processes that were required just to handle the increased size. So for an example, one thing they had to try to do was maintain panel weight below 50 pounds. So what that does is that makes sure that one person is able to mount them, that you don't have to have multiple people, you don't have to use a crane to mount some of those panels, things like that tend to slow down manufacturing efficiency. So those were things that they were thinking about. They were also thinking just from an ergonomic and safety standpoint, the smaller we can, or the less weight we can have these panels be, the better for our people in the long run. So there were a lot of those kind of considerations that they haven't run into in prior designs with other housings. So that was a really big one. This is the first product, right? We talked about that 29,200 CFM. That was a big jump in airflow for us. And what that meant is that we had to increase the number of supply fans, which we have only ever used up to 2 supply fans in any of the housings at this point. This housing could have up to 4 supply fans. So they actually had to redesign how fans fit in the cabinet and switch from a side-by-side design to a stacking design when they do have all 4 of those. And that had some just inherent design challenges with it being the first time that they had done that. So that was a fun one to overcome. We kind of beat the end condensing section already, but end condensing, that was a brand new concept for our team. So lots of testing, lots of time in the lab on that one to see what layouts made the most sense. I know they played with different coil mounting. So they ended up in that V shape, but I know they had considered a W shape. They had considered some different wraparound styles, things like that as well. So a lot of time spent in the lab on that. Talking about foam again, so that injected foam, again, that can be a pretty messy and tedious process, but the foam calculations for the larger panel sizes, surprisingly challenging. Again, this is where it comes down to sometimes this is a bit of an art and a science, and so that was a surprise, to say the least. And then we also just did some things for serviceability. So again, kind of those compressors being outside, we had to figure out how do we put the inverter VFD in a spot that's still close enough to them, well protected from the elements. We actually did a stepped design for door fitment on this housing to make sure that the doors fit really well. So that was a different design that we hadn't had to do before. Again, kind of comes down to how heavy they are and things like that. But lots of little things that I never would have expected after talking to the engineering team on this one. So in case you were curious where outdoor products are made, because that was the last bit of information I had on kind of the new product out there, but the applied products are made throughout the US. Right now, we're seeing them in Schofield, Wisconsin. That's where a lot of your standalone energy recovery is going to be built. When it comes to your RV, RVE, RVC products, those are Tulsa, Oklahoma, and Kings Mountain, North Carolina right now. Also, can't forget Shelby, North Carolina for a couple of those as well. And then RTUs, or the rooftop product, is also going to be built down in Tulsa. So if you actually look at the square footage of space that we have currently dedicated to just applied products in general, it's quite a bit. I think they related it to how many football fields it would be at one point, and it was like over 5 football fields. So it's a lot of space just for applied product, but we're not done. We know we announced a new campus going in Knoxville, Tennessee. So we know eventually we'll see applied product in Knoxville as well. We just don't know when at this point. So that is kind of where they're all made. And then if you wanted to see all the applied product on one screen, that is kind of where we're sitting with that new indoor energy recovery, the new rooftop, and then that new RV model as well. So that being said, lots of details in there. I am going to turn it back to Tracy and the Holden team, and we can do some questions if you guys have any.